So this video will serve as an overview of how to use Excel to work with time value of money problems, right? So the first one we're going to look at is what we call a future value of a lump sum. Future value of a lump sum is, for example, we put $1,000, let's say, in the bank today, and we would like to know how much that would be worth at the end of 3 years. Excuse me. Now, if we wanted to, we could do this by hand each year. Numbers are relatively straightforward. So if we come down here, we see we're putting $1,000 in the bank today at 10% compounding rate per year. At the end of 1 year, that'd be worth 10% more, 1,100. At the end of the second year, we'd be adding another 10% to what we had. So 10% of 1,100 is 110. So add 110 to 1,100 to get to 1,210. And then it's going to grow one more year at 10%. So 10% of 1,210 is 121. We'd add 121 to 1,210. We end up at 1,331. So we would call the 1,331 the future value of a lump sum of $1,000 invested today at 10% at the end of 3 years. So let's see how we use Excel to do this. So I've got my input area set up already. The amount invested today, that's known as PV in Excel terms. Here's the compounding rate. As we'll see, that's known as the rate in Excel. And the time period, in this case, number of years. As we'll see, the Excel function there is NPER. All right, what we're trying to calculate here is the future value, FV. So the way I like to do these particular problems is to use this F sub X button up on the formula bar. So double click on F sub X. And a couple ways you can do this. Here's this category drop-down arrow. If you go to category, what we're looking for are the financial set of functions. Right? And I'm looking for something to deal with future value. I happen to know it's FV, but here's FV, and it tells us this returns the future value of an investment. Okay, so that's what I want. So I'll click on that. And now what this prompts me to do is to just enter some of these inputs. So the rate, and there's a couple ways to do this. One is much preferred way of doing that. In these boxes, never enter the actual number. Always use a cell reference. So for the rate, while I'm clicking in the rate box here, I'll go out and click on the cell that is 10%. So notice this says equals B2. So it's referring to cell B2. And over here it tells me that the value of that cell right now is 0.1. There's the NPER. That's referring to the number of periods. Okay. So that's where I have my 3. So again, that's cell B3. The payment I skip. If I click in this box, this says the payment made each period. We're not making payment each period. We're just putting $1,000, let's say, in a bank account today, not doing anything to it, just letting it earn interest over the next 3 years and seeing how much it's worth at the end of 3 years. We'll come back to the payment when we get to annuities. So the last thing I need to fill in is the PV. Okay. And as you see down here, the PV is the present value or lump sum amount, right? That's going to be cell reference B1. But notice, you can see right here, it gives me the answer before I hit OK. Notice there's a negative sign in front of this. Okay. By default, Excel considers PVs and FVs to be opposites of each other, right? So one way to think about it is perhaps if you think of the PV as an outflow, you're giving $1,000 to the bank. Then after 3 years, you're getting it back. It's an inflow. So one is an outflow, a negative. One is an inflow, a positive. Right? So it's just nice from my perspective to not get a negative answer. It's going to show up in red. It looks kind of odd. So what you do to trick Excel here is put a minus sign in front of that B1 reference. So right here, I put a minus sign in front of B1. Notice the answer is still 1331, but it's positive. So I hit OK, and there's my answer. Right? We already knew what it was going to be. That's how we can do it in Excel. Right? So there's the future value of the lump sum. Let's do the present value of the lump sum. So the present value, notice what we're going in reverse order. The phrase we use, we're discounting. We're going from a future value to a present value. Right? So the direction of the arrow, again, we can see here. So we're going to use the same numbers just so we know what the answer is. So let's say that in our mind, we're thinking we would like to have at the end of 3 years, $1,331. That's our future value. And we want to know how much would we have to put in the bank today in order to have 1,331 3 years from now. Like I said, we already know the answer is 1,000. But here, if we want to start going backwards, we're instead of on the previous slide, if you go back for a second, what I was doing here if you look at my cell here, formula, I took the value from the prior year multiplied by 1.1, 1 plus the interest rate of 10%. So that's where it went up to 1,100. Then the next year, I take the value at the end of the prior year, multiply that by 1.1. And for the final year, take the value from the year before, multiply that by 1.1. Right? With PV, we're sort of doing the opposite, so we divide. So notice to go from 1331 to 1210, what I did, I took 1331 and divided by 1.1. To go from 1210 to 1100, I divided the 1210 by 1.1. And finally, go from 1100 to 1,000, I divided that by 1.1. Now, again, with 2 or 3 years, you can do it by hand, something like this, not too time consuming. But what if it was like 30 or 40 years? You wouldn't want to have to keep creating that formula over and over. That's where these financial functions come into play. Right? So here, what we're solving for is present value. Once again, I'll use the F sub X button. Right? I'm still in the financial category. If you're not, select financial. And we're going to scroll down till we get to PV. There it is. So double click on PV. Let's see what they want us to fill in. So once again, we use cell references. So the rate is the 10%. The number of periods is the 3. Skip payment once again. And the future value, once again, since we want to get our answer in a positive number, I'm going to trick Excel by putting a minus sign here and clicking on the 1331. Right? And notice we get the value of $1,000. Right? So PV and FV are sort of mirror images of each other. One is just going from the present into the future. The other, and we call that compounding. The other is going from the future to the present. We call that discounting. Right? And those are lump sums. Right? Now we're going to move to annuities. Okay. So annuities are where you make multiple payments. And you can either calculate the future value or present value of those. And we have to also be careful. There's 2 different types of annuities. Right? One is called an ordinary annuity, as we see up here. In the first cell A1. Then down here in cell A9, we have something called annuity due. The difference between them is when does the first payment of the annuity begin? The first payment occurs at the end of the first period. We call that an ordinary annuity. If the first payment begins at the beginning of the first period, we call that an annuity due, right? So I tried to draw this. So again, let's say there's initially, we have an ordinary annuity. It's 3 years in length. Right? It's going to be 10% compounding interest. And it's, again, for 3 years. So I try to sketch this out over here. So notice the very first payment doesn't happen until the end of the first year. And we're trying to figure out, in this case, what is the future value of this annuity? So that one, we're making a payment at the end of the first year. And we know how much is all this going to be worth at the end of 3 years. So that one has a chance to grow for 2 years. So if we wanted to, that's individually a lump sum. The future value of $1,000 at 10% for 2 years. We already calculated that before. That was 1,210. Right? Go back here. We saw that, right? Here's the future value of $1,000 at the end of 2 years, 1,210. Right? Then we make our second payment at the end of the second year. Okay. And that has a chance to just grow for 1 year, from the end of the second year to the end of the third year, right? So that'll be worth $1,100, right? 10% growth. And a third payment occurs at the end of the third year. So how much is $1,000 at the end of 3 years? If we're getting it or making the payment at the end of 3 years, it's worth exactly $1,000, that last one. That one didn't have a chance to grow at all. So we're putting the $1,000 in the bank the very last day of year 3. We're asking, well, how much is that worth on the very last day of year 3? It's worth what we put in there. So to get the total amount of this annuity, we add these 3 numbers up, we get 3,310. Let's see how this works in Excel. So we got it set up. We're going to once again use f sub x. In this case, we are looking for FV again, the future value of this annuity. So the rate is the 10%. The number of periods is the 3. Now we do use the payment box because we are making a series of payments. Again, we're going to trick Excel by putting in a negative amount for the money that's outflow, so we can calculate what is the inflow, and that'll return a positive answer. And that's the 1,000. Okay. Right. Let me see, did I hit the wrong, I hit the wrong cell here. So the number of periods is B4. There we go. Or we see our answer 3,310. Right, so let's hit OK. So the matches, we already knew that was going to be 3,310. Right? Now let's look at an annuity due. The difference is in annuity dues, it's still going to be 3 payments of 1,000, and we want to know what is the future value of those 3 payments of 1,000. The difference between annuity due and an ordinary annuity, with the annuity due, notice the first payment is at the very beginning of year 1. Second payment is at the beginning of year 2. The third payment is at the beginning of year 3. So in this case, if you think about that first payment we make, that is a chance to grow for 3 full years, right? All of year 1, all of year 2, all of year 3. So that one right up there, that's essentially just looking at one payment individually. Its future value at the end of 3 years is 1,331. That's the same as what we did here. What is the future value of $1,000 today at the end of 3 years? So that's where the 1,331 is coming from. These other numbers, what's the present value of $1,000? That has a chance to grow for 2 years. That's the 1,210. And what's the present value of $1,000? That has a chance to grow for a full year, 1,100. So we add those 3 numbers up. We get the future value of this annuity is 3,641. Right? Let's see how we do it in Excel. Right? So I'm going to come over here to this cell. We're going to solve for this. Once again, hit the F sub X button. Right. Scroll down till we get F sub X. I'm sorry, FV for future value. And let's start filling what we need. So the rate is where there's the 10%. The number of periods is where I have the 3. The payment with the minus sign is where I have 1,000. Right? And this time we have to use this type box. We didn't talk about it before. So notice what type stands for. Type is a value representing the time of payment. The payment is at the beginning of the period. We have to put in a 1. If it's at the end of the period, we can put it a 0 or omit it. That's what we did up top. When it was an ordinary annuity where the payment occurs at the end of the period, we could omit a value there. We'd have to put anything in. But in this case, since they occur at the beginning, we have to put a 1 in here. So notice we're getting an answer of 3641. We already knew that, right? So there's the difference between the ordinary and the annuity due. Right? Let's do one more, and then we'll stop this video. We'll make a new one for the rest of these present value calculations, time value money calculations. So now we're just going to do present value of annuities. So this is going from payments that we're either making or receiving in the future and discounting them back to today, right? So in both cases, it's the payments are 1,000, the discounting rate is 10%, and it's 3 periods. Right? So let's see how this works. So again, with an ordinary annuity, the payments occur at the end of the period. So at the end of year 1, that first payment, we discount that back 1 period by dividing it by 1.1. Right? The next payment occurs at the end of the second year. We need to discount that back 2 periods. That's going to be 1,000 divided by 1.1 raised to the second power. Right? And then the last one is going to be 1,000 divided by 1.1 raised to the third. We're doing it 3 times. Right? So we can see what those numbers work out to be. We add those 3 up, we get 2486. So let's see how we do this in Excel. So we use F sub X. We're looking for PV now. And let's see what we need here. So the rate, 10%. Number of periods, 3. The payment with a minus sign is the 1,000. And again, the type we can ignore or put in a 0, just ignore it. Say okay. So there's the 2486.85. For the annuity due, notice it's different. The first payment took place at the beginning of the year. So we're asking how much is $1,000 that we received today worth today? Well, it's worth $1,000. Then at the beginning of year 2, essentially a year from now, get $1,000. We want to know how much is that worth now. So that we have to divide by 1.1. And then the last one, we receive a payment at the beginning of year 3, and figure out how much that's worth at the beginning of year 1. We have to discount that for 2 periods. So 1.1 raised to the second power. Okay. So we see the total there, 2723. So let's figure this out. F sub X. Let's scroll down to PV. Rate, 10%. Number of years, 3. The payment with a minus sign is 1,000. And for type, we need to put in 1. Okay, and we get the 2735.54. Right? So let me stop sharing here.